In this video, we are going to look at how part properties, tolerances, and search settings are configured in the software. As you can see here, all of these settings are grouped into tabs at the top. Let's start with Part Properties tab. This tab contains the general settings that change machining behavior and optimization. First, here you can set the part quantity, which simply means how many identical parts will be produced and machined. Next is work holding rigidity. Work holding rigidity describes how firmly the part is clamped during the machining. Based on this setting, software automatically adjusts the cutting aggressiveness. Cutting aggressiveness controls how much of the feed values from the NX library are used during simulations. Here you can fine-tune this using this slider, but in most cases, suggested values work well. Then we have end mill search intensity. This controls how deeply the software searches for suitable end mill tools. It is clear that a higher setting can improve the result, but in the same time increase the computation time. And finally, at the bottom, you can select which machines are allowed to machine this part. In the second tab, the initial stock material, called as the blank in manufacturing, is defined. The blank represents the raw material form from which the part will be machined. Here, the software provides three options for defining the blank. The first one is the bounding box, which creates a rectangular stock around the part. The second one is the bounding cylinder, which creates a cylindrical stock and is mainly used for turning operations. But note that the cylinder axis must be defined correctly, as it determines the spindle directions in turning operations. And finally, the step file option allows an external stock to be imported for the simulations. Then, if the selected machining option includes rough milling, the software automatically determines and lists an ordered set of recurrent setup directions, which defines the sequence in which the rough milling setups are evaluated. And only these listed setup directions are checked during rough milling in the simulations. The filtered setup orientations are shown in table below and can be added to active list if required. The order of setup directions in active list can be changed using these arrow buttons. Also, if you press the highlight button here, it visualizes the selected setup direction on the model for you. The third tab in this user interface is used to define tolerances for the part and its features. At the top, a general tolerance complexity can be selected, where this setting applies default tolerances to the entire part and all recognized features on it. The tolerances can be also adjusted separately for the part and individual features below. When a feature is selected from the list, it is highlighted on the model. For each feature, the tolerance can be selected individually. Additionally, if a specific set of machining operations is required, it can be assigned here. If no operation set is selected, the default algorithm automatically assigns the most suitable operation set for each operation from the strategies. Machining strategies can also be updated in this tab, as described earlier in the main interface. To apply strategies edited in this interface, click the refresh button here. The search setting tab in this interface is used to customize search parameters for optimizing the sequence of feature machining. Here, the search mode defines how the software explores different machining sequences. The greedy search evaluates the features one by one. This mode is not recommended as it may not produce an optimal sequence. The shallow search explores a limited number of sequences and fast results. The moderate search balances search depth and computation time. The deep search explores more combinations to find higher quality optimized solutions, but as it's clear, it requires long computation times. The user-defined mode provides advanced search settings. This mode requires knowledge of the RRT-based search algorithm and it is intended for expert users. Also here, you can define additional machining parameters which will be used during the simulations. For example, you can define the setup change time and tool change time, the times required for changing the setups and tools during the simulations. You can also define the maximum acceptable error, which defines the allowed deviation during optimization. This error value controls how strictly solutions are evaluated during the search. Once you set all the parameters, you can click OK and the workflow continues.